Today we're going to talk about probability of different types of events. You guys have done simple probability for a long time, so you already know how to do that. So what we want to focus on is when you have a little more complicated probability events. So some vocabulary that we're going to start with is mutually exclusive and inclusive. Mutually exclusive events are two different outcomes, but they don't have anything in common. So this has no outcomes in common. Okay, so like if we were randomly picking students from the student body, we could say, what's the probability of picking a sophomore or a freshman? Those would be mutually exclusive events because you can't be a sophomore and a freshman at the same time. Is that what I said originally, or did I say seniors? I can't remember. Anyway, so like what grade you're in is a mutually exclusive. Inclusive would mean that there's overlap. There is overlap in outcomes. So if we were randomly picking two students and we want to know the probability that they're in band or choir, well, it's possible that there's overlap there. You could have a person who's in band and choir. So that means the math that we do to find probability is different. So if it's mutually exclusive, if they have no outcomes in common, if we want to find the probability of A or B, we just take the probability of A plus the probability of B. If they're inclusive, if there's overlap, we still take the probability of A plus the probability of B, but then we have to subtract the overlap, the probability of overlap. So that way we don't double count the overlap. So we'll do a couple examples with this. So first we're going to decide if it's mutually exclusive or inclusive, and then we'll do the probability. So Kara has 8 baseball cards, 5 basketball cards, and 6 hockey cards. If she selects a card at random, what's the probability that it is a baseball or hockey card? So we want to know probability that it is baseball or hockey. Now, what I want to know is there any overlap here? Is there any overlap between types of cards? And there is not, so this is going to be a mutually exclusive event. Okay, so to do mutually exclusive, all we have to do is find the probability that she picks a baseball card and add that to the probability that she picks a hockey card. So probability of baseball, let's see, she has 8 baseball cards out of a total of 19, hopefully 19. And hockey, she has 6 out of a total of 19. So if you add those together, the probability of picking baseball or hockey is 14 out of 19. We always want to reduce our fractions, and then I often convert it into a percentage because 14 19s, I don't know, it's kind of hard to think through what that might be. So if you put that into your calculator, it's about 74%. All right, out of 1,400 students, 550 take Spanish, 700 take biology, and 400 take both Spanish and biology. We want to know what is the probability that a student selected at random takes Spanish or biology. So before we can do this problem is we have to decide, is there overlap? And there definitely is, because we have some students who are in both. Okay, it's not like you're just taking Spanish or just biology. So we would call this an inclusive event. So to find probability of inclusive events, we want to know the probability of getting someone in Spanish class, plus the probability of getting someone who's in biology, and then we want to subtract out the overlap. I'm just going to call it both. All right, so the probability of getting taking Spanish is 550 out of 1,400. The probability of biology was 700 out of 1,400. And then we need to subtract the overlap because, like, if Logan is in Spanish and biology, we have counted him twice, so we need to subtract our overlap so we don't double count all these people who are in both. So people who are in both are 400 out of 1,400. And we're just going to add that up, which is 850 out of 1,400. And again, we want to reduce that fraction, which is 17/28. Your calculator can help you with that. And then I like to turn it into a percent just because I don't know what 17/28 is off the top of my head. And it turns out to be right around 61%.